Hello and welcome to Technological News. Today I will talk about overcoming the physical limitations of today's telecommunications. Human skills will be digitalized and democratized in a full time, regardless of where you are or where the problem to be solved is. Consider a highly specialized surgeon performing a telesurgery on a patient thousands of kilometers away, in which, despite the fact that a robot is using the scalpel, the operation seems as real to the surgeon as if she were using the scalpel with her own hands. Physically impossible. This vision, however, is not feasible today. This is due to the fact that reproducing the sensation of touch, utilizing forces, vibrations, or movements on the user, and thus fooling the skin and body into thinking that what we are feeling in the virtual world is genuine, demands a network with sub-millisecond latency, networks with ultra-low latency and ultra-high bandwidth, in which operation, command, and haptic feedback occur end-to-end with a maximum delay of 1,000th of a second. Such extremely low latency limits the maximum communication distance only to 150 kilometers. Even under ideal conditions, light cannot travel any further, but information has to move backwards and forwards between the human operator and the remote slave robot within the latency bound. Enabling real-time transmission of haptic sensation over the internet will potentially allow diverse physical operations without humans being physically present. This will pave the way towards the envisioned Internet of Skills, which will better disperse and democratize skills and expertise among people regardless of gender, age, and other diversities. This can reduce the amount of travel-associated carbon emissions. However, the required level of immersion is unattainable over long distances at this stage. Hence, novel solutions are needed to address the challenges, says Associate Professor Q Zhang from the Department of Electrical and Computer Engineering at Aarhus University. Q Zhang is heading a new research and development project called the eTouch, which aims to overcome the physical limitations of today's telecommunications. The aim is to create an immediate response regardless of distance so that haptic feedback can be perceived by the user without noticeable delay. Even though the communication is at a distance of thousands of kilometers, to solve this problem, the team will leverage model-mediated teleportation, in which a virtual model will accurately describe the remote environment and which locally generates the haptic feedback instantaneously instead of transmitting it over long distances. However, it is quite challenging to create an accurate model and make effective and reliable model updates in real time with the current data processing paradigm. Therefore, the team will use edge computing paradigm. It has many industrial applications. Therefore, the team will include world-class experts in the field of edge computing, tele-robot technology, and machine learning in the technical. But if our method works, it could be groundbreaking for the internet of the future and enable the spread of tactile internet over intercontinental distances and perhaps even in space, says Q Zhang. One of the biggest trends of the future, the Danish company Rope Robotics is developing robots that can replace the manual labor that is currently required to maintain and repair wind turbine blades. The goal is a robot system that can crawl around on the wind turbine blades and clean, grind, polish, and paint them without human interference, which would cause less accidents